Hello, this is number 3. Number 2, I posted a picture of, and I hope that those answers make sense. If they don't, let me know, and I'll go through that one as well. But here we go for number 3. So now we have a table. So they're going to be requiring some Riemann sums. So I thought this would be a good one to go over. So number 1, notice that this is the rate. The rate at which water flows out of a pipe in gallons per hour is given by differentiable function R. The table above shows the rate as measured every 3 hours for a 24-hour period. So notice that this is a rate of gallons per hour. So if I integrate the rate, I'm going to get number of gallons. So just to keep that in mind, that's the really important, calculus concept going on. So letter A, I use a midpoint sum, Riemann sum, with 4 subdivisions of equal length to approximate the integral from 0 to 24. Using correct units, explain the meaning of your answer in terms of water flow. So first of all, we're going to have to calculate a Riemann sum. So this is a good thing to practice. I don't know if you want to make a picture. Sometimes I like to make an actual little table of values and put points up so then I can have little rectangles and I can be looking at them. But sometimes I can also just kind of figure it out myself. So if we're using a Riemann sum with 4 subdivisions and I have to go from 0 to 24, how big is each one going to be? Well, I'm going to go from 0 to 6. I'm going to go from 6 to 12, from 12 to 18, and 18 to 24. So don't let that seem confusing, like I'm going over 3 and then only 2. I'm going to count 6, and I'm not counting 6 down because they want 4 subdivisions. So if I break 24 into 4 parts, they would each be 6 wide. So from 0 to 6, 6 to 12, 12 to 18, 18 to 24. So when I think about how to calculate that, each rectangle is going to be 6 wide times the height. So it's a midpoint sum. So I'm going to use the middle value of 3, and I'm going to use the y value that goes with that. So 6 times 10.4 plus 6 times, so halfway between 6 and 12 is the 9, so 11.2, plus halfway between this section is going to be at the 15 at 11.3, so plus 6 times 11.3, plus between 18 and 24 we have 21, 6 times 10.2. Put that all together, and I think I have the math already done. Yep, I get 258.2. So explain them, or using correct units, explain the meaning of your answer in terms of water flow. So what is this? This is the number of gallons, or this is an approximation for the number of gallons. So this is the, this number estimates the number of gallons that flowed out of the pipe from time equals 0 to 24 hours. Okay, that's what they're looking for that. So letter B, is there some time t between 0 and 24 such that the derivative of r is 0? This is asking you about Rolle's theorem. They're saying, is there some time between 0 and 24? Well, look at that. I'm going to get a different color just to be crazy. Between 0 and 24, look at the y values. They're the same. So that means, by Rolle's theorem, that there has to be a place in between 0 and 24 that the derivative is 0. I also know that because it tells me that r is a differentiable function. If it didn't tell me that r was differentiable, then I wouldn't be able to say that. So when it says justify your answer, I'm going to have to say, because r is differentiable and because r of 0 equals r of 24, there must exist some value such that the derivative is 0, or you could just say by Rolle's theorem, r prime will be 0 somewhere on that interval. All right, part C, the rate of water flow can be approximated by this function. Use Q of t to approximate the average rate of water flow during the 24-hour time period. Average rate is now asking me for average value. This is an average value problem. I know that because the rate is what this represents right now, and they want the average. So they want the average value of that rate of water flow. So I'm going to find the integral of Q of t with respect to t on the 24-hour period, so from 0 to 24, times 1 over 24 minus 0. And I have a calculator for this, so I get approximately 10.785 gallons per hour is the average value. So that means if I were to graph this from 0 to 24, whatever that looks like, it's a parabola upside down, the area underneath of it from 0 to 24 will be the same as the area under the rectangle that has a height of 10.75 from 0 to 24. So the area underneath this pink rectangle will be the same as the area under the blue, because the extra blue space will fit into the spaces of the pink rectangle. But anyway, indicate units of measure. So there we go, 10.87 or 785. Hopefully that makes some sense.